Hello, geometry, and another part of our circles unit, circles 104 is what I'm calling this one. Really, I can call this surface area and volume with circles in it, because that's what this particular part of the unit is on. So when I look at the circles, and we've already talked about what the circumference is and the area is, and what their diameter is, and a radius, and a chord, and all those different angles, and how we would find the area of a sector, and how we would find, all those different parts of the circle. Now, what happens if we start taking those parts of the circle and we start moving them into the third dimension? How does that still affect the area and the surface area, or the volume, the total space inside the object? That's what this video is going to talk about. So, first thing we want to go back to is review a little bit about a circle. If I have a circle, I have a radius, or I might have a diameter, but I'm going to say in this case I have a radius, and a diameter would go all the way across. And now we know the circumference is the distance around the circle, and that circumference is pi times the diameter, or it's 2 times pi times the radius. That's the easiest way to think about those. And the area of that circle is pi times the radius squared. So that would tell us how many little square units would it take to completely cover the circle. So those are the two things on the circle itself. But what happens when we go through dimensions? We start looking at surface area and volume. Volume is the space, notice space, the three-dimensional space inside this object. And I might refer to it as a solid, so just to let you know. Where surface area is the number of square units to cover the object. So how much is it going to take to completely go over the top and around it? So you can think of surface area as the wrapping paper, and volume as how much can you get in there. So let's take a look at the sphere itself. Okay, the sphere, here we have a nice sphere that we can see, and we're told, as we look at the picture, we have a center, and we have a diameter, and we have a radius. And notice this little thing right here that they call a great circle. The great circle is a circle that happens to contain a radius and a diameter. So that goes all the way around the circle. Really what a sphere is if I take a circle and I spin it, rotate it around one of its diameters, I get a three-dimensional circle. That's a sphere. I don't know if you can see these real well, and I'll probably have to write over the top of them. That's what I'll need to do. There we go. I want a nice white color here if I can. Thank you. Okay, so the diameter of the sphere is 2 radiuses. So that would be the diameter. It's 2 radius, and the radius is just, that. Okay. We still have a circumference, and it's still 2 pi r. Again, that's just going to be the distance around the great circle. That's really what it is. Now the surface area of the whole sphere, based off of mathematical calculations, we found it to be 4 pi r squared. 4 times the area of the great circle that's on the inside. Rather cool, actually. Now, if we think about other shapes that we have, we can find the volume. And the volume for most shapes is the area of the base times the height. Well, in this case, the height would have to be, kind of like a diameter or a radius, and the base would be like the circle, but the problem is it's not completely there. So we have a formula for it, and it's 4/3 pi r squared. And we can go through the whole explanation personally if you want to talk about why it is that way. And then I'll show it as we get into some of these other shapes. Okay, so now let's look at the hemisphere. Well, the hemisphere is really just a great circle and the half of the sphere that's above it or below it or to the left or to the right of it. Okay, again, its diameters can still be 2r. Its circumference around the great circle is still going to be 2 pi r. Its surface area won't be 4 pi r squared because it's half of the whole thing rather than the whole thing. But when you look at that, if I do half the surface area, I would get like the rounded portion of the semicircle if I just took the surface area of the whole cylinder and divided it by 2. but I also have the great circle there. So the surface area of a hemisphere is 3 pi r squared, which is really 2 pi r squared plus the great circle, which is pi r squared. So if you've ever get a chance, go down to Arizona and you get to see the biodome down there. If I wanted to find the surface area of the glass that's in that, I wouldn't do the whole 3 pi r squared because you're not going to put glass on the bottom of the dome. It would be the 2 pi r squared. So you got to kind of think about what that is. And sometimes that's referred to as the lateral area. Now the volume, though, is exactly half of the whole sphere. So instead of 4/3 pi r squared, we would take 2/3 pi r squared. And that's going to get us the information there. Now, what if I take a cylinder, or I take a circle, instead of spinning it, I just translate it into a three-dimensional tall object, I get a cylinder. Now, a cylinder, again, diameter of it's going to be twice the radius of it. The height of the cylinder is the distance between the bases, and that's why I got a B on the bottom. That's kind of the base. And how would I find that base? I would take pi and multiply it by the radius squared. That would be the area of that base. So to find the volume, I'm going to take that base and multiply it by its height. So that would mean I'm taking pi r squared times the height of the overall thing. I like to use a capital H, knowing that it's the height of the whole cylinder, the whole thing. Now, when I go to find the surface area, I've got to think of what this would look like if I laid it out flat. And the surface area is going to look like 2 circles. So that's going to be 2 of these pi r squareds. Plus, I'd have this big rectangle. And the rectangle's height, or length and width, the one that's going to be the height, the other is going to be the distance around the circle. Well, the distance around the circle, as we know, is the circumference. So that's 2 pi r times the height. So there's its formula as well. And now let's take a look at the next one I have here. Is I have a cone. Oh, I forgot to bring one in. Let me get one real quick here for us. Come on. Shapes. Come on. Solid. That's what we want. We want a cone. We want a transparent cone. There we go. That'll work better. Okay, so I have a transparent cone. So now when I look at it, again, I have the circle, and it has a radius. But notice it's got a direct height. I'm going to make a capital H there. But it's also got the height along the edge. I'm going to call that L. Okay, so it has a direct height, and it's got a slant height. Now the thing to notice here is the height, the radius, and that slant height create a right triangle. So the overall height of the object and the radius are like the 2 sides of a right triangle with 2 legs, so they would have to equal the slant height squared. Just a tad bit of information there. So now, if I'm going to find the volume of this, I have to, again, find the volume of the bottom. So that's pi r squared. And then we always like to take that base area and multiply it by the overall height. Now, since it's a cone, that means it's not completely the circle straight up like it was for the cylinder. But if I take this and I divide it by 3, I get the volume of the cone. And again, this is one of those. If you want to talk about a one-to-one, I can talk to you about why we have to divide by 3 and what's the mathematical principle behind that. Now let's talk about the surface area. When I look at the surface area of this, I do have the area of the circle on the bottom. But then I have the cone itself. If I was thinking about, like a snow cone, it would be the paper holding that in. What is the area of that paper? Well, when I look at it as a general thing, I see that it is a triangle, which means I'd have to take half the base times the height. Well, really, that's what we have to do. But the height is the L, that slant height, and the base is the distance around the circle. So I would have to take 1/2 times the circumference times the slant height. But half times 2 is just 1. So my formula says it's pi radius slant height. Okay, So there's the formulas. Hold on to those, read them written down. So you got these formulas that you got written down. If you don't, rewind the video, get all these formulas written down. So now we got problems. I want you to find the surface area and the volume of each. Okay, I'm going to switch to a finger pen, that'll work better. Okay, surface area and volume for each one of these. So all I have to do is use the formula. Let's start with the sphere, since it was the easiest one on the list. The surface area is 4 pi radius squared. So 4 pi times 3 squared, which would be 3 squared is 9 times 4, would give me 36 pi square feet. That would give me an exact answer. And ideally, I would want to keep the exact answer for these problems. But if we talk to a carpenter or somebody, they're going to want something that's a little less exact, it's something that they would actually be able to look at. So if I take 36 times pi, I get 113.1 square feet. That would be something a carpenter would want to see. The volume, on the other hand, is 4/3 pi radius cubed, which means it's 4/3 pi times 3 cubed. So if I multiply that out, 3 cubed is 27 times 4/3. I get 36 pi cubic feet. Didn't mean for that to happen. It is not always the same. Mathematically, it just happened that I chose a radius of 3 that this worked out, which means this also happens to have 113.1 cubic feet of space. Not always the same. It's going to depend on what the radius is. Okay, so there's that one. Now let's take a look at the cylinder. Surface area is 2 pi r squared plus 2 pi r h. So if I use that formula, and I plug in my numbers, I would have 2 times pi times 3 squared plus 2 times pi times 3 times 8. Why 3? Because we're shown that the diameter is 6, so that would mean the radius is half of 6. The radius would have to be 3. So 2 times 3 squared is 18. 2 times 3 times 8 is 48. 18 and 48 is 66, if I remember right. So my surface area exact answer is 66 pi square inches. And if I multiply that actually out, I would get around 207.3 square inches to completely cover that thing. So if I think about that as a can, say that's a can for food, I would need 207.3 square inches of metal to make that can. Now the volume is pi r squared height. So pi times 3 squared times h, or times h, the h is 8. That's the distance between circles, that's the height. So that gives me 9 times 8, that's 72 pi cubic inches. Now if I multiply that out, I get 226.2. Now, where am I getting this pi from to use? Am I just using 3.14? No, I'm using the pi button on my calculator. So it gives me that longer decimal value. Okay, so now let's look at the volume and the surface area of the cone. Okay, the surface area, according to our things, is pi r squared plus pi r L. I don't have an L. I don't have that slant height. So what do we do? The first thing I need to do is realize that my radius is going to be 3. So I got to use that fact that the radius squared plus the height squared is going to give me the slant height squared. So if I think about that, I have 3 squared plus 4 squared would be 9 plus 16 would be 25. So I get a height, or a slant height, of 5. So now I just plug in my numbers. Pi times 3 squared plus pi times 3 times 5. 3 squared is 9, 3 times 5 is 15. 9 and 15 gives me 24 pi square inches. And if I multiply that out, 24 pi on the calculator, I get 75.4 square inches. Surface area is an area, it's a squared units. How many little squares will completely cover it? Okay, the volume inside this, according to my formula, is pi radius squared times the height divided by 3. So if I plug in my numbers, pi times 3 squared times 4 divided by 3 gets me 12 pi cubic inches. And if I actually multiply that out, well, that doesn't look right. Wrote it right, it just didn't look right. Put it over here. 12 pi cubic inches, or approximately typed in the wrong number there, 37.7 cubic inches. So that's how we calculate surface area and volume of anything that had a circle as part of its construction, whether it's the sphere or the hemisphere or the cylinder or the cone.